Today's lesson is 3.2, slope. Once again, copy your work onto your toolkit. What we will learn today. Today we will learn to find the slope using a graph, table, or the slope formula. So 3 different ways of finding slope: graph, table, or the slope formula. So let's start by talking about slope. Here in this graphic, it tells us to find slope using a graph or table. Slope is a rate of change. We talked yesterday about, or in lesson 3.1, about constant rate of change, while slope is a constant rate of change. It can be positive, slanting upwards, or negative, slanting downward. So slope is rise, and the rise is the vertical. Vertical means up or down, change between any 2 points. Run is horizontal, change between the same 2 points. Horizontal will be left or right. Our first example asks us to find the slope of the treadmill. So we're going to use the formula slope is equal to rise over run. So once again, the rise is the vertical, so going up and down. So going up and down, this treadmill is 10 inches. And the run going across is 48 inches. Pretty much it's going to be 10 over 48, and we want to simplify this. Now, I know that into both of these, the biggest number I can think of that can go into both 10 and 48 is 2, so I'm going to divide by 2. So 10 divided by 2 is 5. 48 divided by 2 is 24. So the slope of this treadmill is 5/24, or 5 over 24. So for every 5 inches it goes up, it goes across 24 inches. For this example here, we have a graph, and the graph shows the cost of muffins at a bake sale. Find the slope of the line. So once again, we're going to use our same formula that we had before in the last couple examples. Slope is equal to rise over run. Now, translating rise and run. If you're going up, think positive. If you're going down, it's going to be negative. So right is also positive and left is negative. So to sum it up, going up or to the right will be positive. Going down or to the left will be negative. So here I'm going to start, and it doesn't matter which point you start at. I'm going to start at the first point that I see, which is the point 24. So I'm going to start here, and it's going to go up 1, 2 places. So that's going to be my rise. So my rise is going to equal 2. Then I'm going to go, and it's positive 2 because I'm going up. Again, going up is positive. And I'm going to go to the right, which is also positive. Let me mark my positive over here for the 2. It's going to be positive 1. So we simplify this. We get a slope that's equal to 2. Example number 3. The table shows the number of pages Garrett has left to read after a certain number of minutes. The points lie on a line. Find the slope of the line. Now here we don't have a rise or run. So what we're going to have to do here is we're going to use a different way. And we're going to find slope by finding the change in y over the change in x. Very similar to what we did in lesson 3.1, where we found the change. So what we're going to do is we're going to find the change in y between 2 points, and we're going to go between 12 and 9, we went -3. And then between 1 and 3, we went +2. So it's plus 2. And so and the time, it's -3 on the pages. So here's our slope. It's going to be -3 halves. Okay. If we were to choose any other points, you can see that it's the same thing. If we were to choose 9 to 6, we're going -3. 3 to 5, we're going +2. From 6 to 3, -3. 5 to 7, +2. It's a linear relationship. They tell us it's a linear relationship because it says the points lie on a line. So as long as we find a difference in 2 points, we should be okay to find our slope. Once again, slope is the same as our constant rate of change.
Slope. A ladder truck uses a movable ladder to reach upper levels of houses and buildings. The term slope is used to describe how steep the ladder is. The slope, or rate of change of the ladder, compares the height it is raised to the distance of its base from the building. We can write this rate as a fraction in simplest form. To find the slope, look first at the height the ladder is raised. The ladder is raised 45 feet. This is called the rise. Compare that to the distance from the base of the ladder to the building, which is 30 feet. This is called the run. In simplest form, the rate of change is 3 divided by 2. For every 3 feet of rise, there is 2 feet of run. The slope is 1.5. Another ladder has been raised 100 feet and has a base of 50 feet from the building. The rate of change equals the height the ladder is raised, 100 feet, divided by the distance of the base of the ladder from the building, which is 50 feet. In simplest form, the rate of change is 2 divided by 1, or 2. So which ladder is steeper? Since 2 is greater than 1.5, the second ladder is steeper.